Morning, everyone. Today I'm going to talk about the torque, which is very similar with forces. Okay, so torque is a kind of a rotational force, and then you can assume this is a kind of force to rotate something. For example, when you open the door, you need a torque because you got to rotate your door, right? So the torque is basically let's assume we have this door, and then let's assume your hinge is the left side of this one, right? And then let's just think about the four different cases of your force. Assuming you apply force at this location with this magnitude, this direction, which is called a F1, and F2 is apply force to the left along the door, and this is F3 and this is F4, and then F1 is the most effective way to open the door. So then now we are investigating what's the differences between force F1, F2, F3, and F4 in order to open this door. Okay, so torque is basically proportional to three parts: R, force, and perpendicular. So for example, let's assume you have a hinge here, you have a door here, and then this is a top view of the door, and you're trying to rotate this door this direction, for example. And then there's a few options you can do, right? So basically, let's assume you're applying your force, for example, 10 Newton of your force, and either here, so you apply your force 10 Newton here, or 10 Newton here. So then which one is easier to rotate? Of course, if you apply your force here, the door will rotate easily. So that's why torque is proportional to R, where R is the distance from the hinge to this location. So this is a R1, this is gonna be R2. So that means that the farther you push it, you can apply more torque. This is a very straightforward, I believe, right? And the second example is about the force itself, right? So now let's assume you apply uh, two different forces at the same location. For example, you apply 5 Newton here, and then you apply same location 10 Newton here. Of course, which one is gotta be proportional to the torque, of course. So that means you can now say torque is proportional to distance r, and then also proportional to force F. And then the most confusing part of this torque equation is about this perpendicular symbol. Okay. And the third question is, what if you apply the same force and then you apply the same location but at different angle? So for example, okay, this is your point of force, where you apply your force. So your R is gonna be same for both cases. And then you will apply same force, which is 10 newtons for both cases. But the first case is you apply your force perpendicular to this line. And the second case is you apply your force this way. And the third way is you apply your force this way. So then all these three are 10 Newton, 10 Newton, 10 Newton, right? And then which one is the most effective way to open the door? Of course, you want to open the door by applying this force. But you can apply maximum torque here, you apply partial torque here. So what here perpendicular symbol actually indicate is, for example, let's assume again your force is kind of diagonal. So that means this is your original force. That means you must decompose your force into two components. So I'll call this as Fx, or F parallel to this axis line, and I'll call this one F perpendicular. But you see here, F parallel actually does nothing to open the door. Only F perpendicular matter. So let's assume this angle is a theta. F perpendicular, which corresponds to here, is a F sine theta. Okay, so this F perpendicular means we only use F perpendicular component as a torque. In other words, F parallel component actually does nothing for the rotation of the door. So this is the same case. You have a pivot here, and then R is here, right? This is the distance from your pivot to location where you apply your force, right? So your torque is here, R, and then now you apply force this way. But everybody see when you rotate this wrench, the best way to apply your force is what? This way, right? Perpendicular to the line that connects pivot and the location where you apply your force. So then you can again decompose your force into vertical component and then horizontal component. And this horizontal component actually does nothing. Okay? So that is called moment arm. And then, yep. So sometimes in general, F perpendicular is called F sine theta for this case, right? So F perpendicular component is a F sine theta because this is the opposite. But I recommend you to don't memorize this one. Instead, you better to memorize torque equation is R F perpendicular. Because why? Perpendicular component concept is more fundamental than sine pi. Because why? Sine phi here means sometimes angle, this theta is given. So then your perpendicular component is what? Force times a adjacent component. So it's a cosine theta for this time, right? So make sure you understand torque is a R times a F perpendicular. So then now the question, we have a four forces shown have the same strength. So all forces are F1, F2, F3, F4 are the same, right? Which force would be most effective in opening the door? Everybody already know, right? So your hinge is there and your door, this is top view of a door. And then how do you open your door? Everybody try, F1, right? Why? Because you guys know that's the most effective way. If you try F4, whose force is the same as the angle are the same as the F1, then what's the differences? R for this F1, F4, this is R4, and then this is gonna be R1, it's much greater. R1 is much greater, so it's easier. Everybody know if you apply your force, for example, here, this is even easier, right? How about F2? If you apply your force along this door, you won't open the door. And then F3, even though you can still open the door, but this is not the most effective way to open the door, right? So the answer is A, right? And then how about here? Ryan is trying to open a stock door. He pushes it at 0.75 meter from the hinge with a 240 Newton force directly 20 degrees away from being perpendicular to the door. And then this is why I said be careful. Okay, don't simply use torque is RF sine theta, but instead you better to understand torque is RF perpendicular. For this case, our torque is gonna be RF perpendicular, where R here is a 0.75. And then F is what? F perpendicular is this times adjacent. So this time you see it's a cosine, right? So this is a 240 cosine 20. That's gonna be your torque, okay? So make sure you don't simply use this formula RF sine pi, because sometimes instead of a pi angle measured from horizontal, sometimes your theta will be given, right? Like this way, right? So make sure, be careful. And then you see your torque will be again 0.75 times up, 240 times the cosine 20, which gives you 170 Newton meter. And then the unit for the torque is a Newton meter. This makes sense because a unit for the R is a meter, unit for the force is a Newton, right? And again, this is a summary, right? So this is gonna be maximum torque, and then this is gonna be maximum negative torque. I will talk about the sign here later, but these two cases, you're not gonna have a torque. This case, you will have a torque, but they're not most effective way. But now, torque is also a vector. Okay, so you need a sign of it. So especially when the object is rotating counterclockwise, we call it positive torque. If the object is rotating clockwise fashion, then we call it negative torque. For example, this force will rotate wrench this way, which is a counterclockwise. So that's why this gives you maximum positive torque. While this torque, if you apply your force this way, and then the whole wrench will rotate this way, right? And then you will have a negative torque because the wrench will rotate in clockwise fashion, right? Again, counterclockwise rotation, positive, clockwise rotation, negative. So then net torque concept is exactly same as the concept of a net force, right? So net force concept is what? If you have an object and then there are multiple forces acting on it, and then we just add all forces as you add vectors, then the sum of all forces is called net force. Here same. If you have a four forces acting on it, and each of these five forces, including the axis one, right? So they apply torque. So your net torque is nothing but adding all these torques. Again, torque has a torque is a vector, so you have to clarify the direction of it. One of them, so if it's a rotating clockwise, it's a negative, counterclockwise, minus, positive. So for example, F-axis actually does nothing, right? Because you apply force at the axis, so you want to rotate the object. So torque due to this F-axis is going to be 0. And how about F1? If you apply force like this way, and then this is your hinge, then what will happen? The whole, the gear will rotate this way, which is a clockwise, so this one will give you negative torque. How about F2? And then this one will rotate this one this way, counterclockwise. So F2 will give you positive torque. And how about F3? This will rotate gear this way, right? So the force is, net torque is up clockwise, so counterclockwise, so positive torque. And then F4 will rotate gear clockwise, so negative torque. So then you have to find each value with the proper sign. You can find the net torque of it. Right? So then, which third force on the wheel applied at point P will make the net torque 0? So basically, in other words, you have another force acting at point P. So basically, you have three torques acting on this, wheel, right? So for example, I will call this is F1, and I will call this is F2. And then F1, what is the torque due to F1? Again, F1 is acting pivot, so that means that this force 1 to rotate this gear right here. So the torque 1 is going to be 0. And how about torque 2? Torque 2, due to force 2, right? This force, second force, will rotate the wheel its direction, right? Which is the counterclockwise. So you will have a positive torque due to F2. And then what is the magnitude F2? Magnitude of torque 2 is gonna be R, which is the distance from pivot to here. Let's say the radius is R, so R times F2 times cosine sine, because at this time this is a perpendicular, so you have a maximum torque. So torque 2 is simply RF2. Then must be clockwise or counterclockwise. The sign is a positive. But how about, so in order to have a net torque 0, you have to rotate this wheel clockwise, right? So then P, direction of the force acting P must be down, right? In order to, and if the force acting on P is down, then this one will also rotate counterclockwise. So that doesn't make sense, right? Because we need a negative torque, right? So you have to rotate everything clockwise. So your force must act over. But now the magnitude. So torque P is gonna be what? Same as this torque. But now the radius is half. So your distance is R over 2. So then in order to make this one stronger, you have to apply 2 times of a force, right? So your force must be 2 times greater than this force. So the answer is A. Okay, today, we have a relatively short lecture, but this torque concept is extremely important, for these chapters. Okay, so make sure you go over, every slide very carefully, especially make sure you understand a perpendicular portion to see, you never use that given equation. Instead, your torque is given by R times F perpendicular. Thank you.